Hi there guys, welcome back. Today we're going to go through the code in Unity for our do-it-yourself game controller. And first of all, I want to show you the game I made. It's not something amazing, but it's a prototype thing that will enable us to use our controller and test it and see how it should work. So, first of all, I have my hardware connected. As you can see, light is red, Arduino is on, it's hooked up to my PC, and I got Unity open as well. So here we have Unity. Where is the camera? There we go. And let's start the game first of all, so you can see what's going on. I have my controller right here, so you can see it. I have the game up here. And the first thing we want to notice is when I start the game, this red one should go green. And when I stop the game, it should go back to red. So there we go. It's green, meaning it's ready. So when I stop the game, it's red. It's not ready. Perfect. That's exactly what we wanted. Going to play again. And going to try out what it says on the screen. It says press number 4. There we go. Press number 2. Press number 1. Press number 2. Press number 1. And if I click a wrong one, nothing happens. Perfect. And of course there is no failure state in this game. It's just a prototype test, so when the timer runs out, nothing actually happens. But as you can see, I'm not clicking button 3, but button 3, and the game moves on. There we go. So let's see how this entire thing is set up. The game itself only consists of 2 scripts and nothing else. The scene is defined by a canvas using the new Unity UI, and it's basically just some text and a slider. This is just one of those sliders you use for a volume control as well. First of all, let's check the code, because that is the most important part of the game. I have 2 pieces of code, and if you notice in my scene, I have a system controller and a game controller. The system controller up here has nothing really, except when I hit play, we get this sound, and when I press a button, we should see something up here. Nothing. Let's check the debug, and now we see a 3. There we go. Also, while the debug is checked, we get a console output. So even though I'm clicking the wrong numbers, I'm getting a count up here, so I can see how many times the buttons are actually pressed, and you can see it's over 100, and that is because the button is bouncing, like we talked about in the last video. But even though Unity is only registering it once, that's perfect. Disable the debug, and that's clear. I mean, we shouldn't receive anything except a win message whenever I'm pressing the right button. That's it. The most important script is this one called COM. It's hooked up to my system controller. The system controller is just a empty game object. I dragged this script on to have it in the scene. You could have it anywhere. Let's open it up in MonoDevelop. That's the wrong screen, but we'll move it right over. There we go. A few things you always need when working with serial connections and Arduinos is system I/O ports, system threading. That's basically it. And for some reason I need this one as well. System, nothing. just the entire system. Usually or previously I was able to develop without using that, but now it's required for some silly reason. I try to comment all the code and make it as simple as possible. So you can see I'm able to close these functions, and now we have actually the entire code on screen. Just like in my Arduino code, I like to organize it, so in my initial phases I just define things. And you can see I have a few inputs or variables defined in the beginning. Excuse me. Well, public static, well, yeah, you know. Anyway, first one is this debug boolean. That's the button we have out here. And then I have my string input. That's the text thing down here. That's because I like to see if there is a problem, what I'm getting actually true to Unity. Then I'm defining my baud rate, just like we do in the Arduino code, 9600, and the COM port. The reason I'm doing it like this is because I want to load it from a option screen. If I were to make a complete game where you would be able to design and play with your own controller, you should be able to change the COM port and the baud rate to match your specific controller without any problems. Alternatively, I would have to make Unity search for all the controllers, and whenever it identifies one, find the correct baud rate and then make it work. This is much easier. Let the user define their own COM ports. If not, then it's COM5 by default. First thing I actually do is define a serial port, my data, and that's just using COM5 and 9600 out here. That's the connection to the Arduino. And then we have our normal code. All this code is only related to talking to the Arduino and forwarding the message from the Arduino into the game itself. So let's see, our start void. I'm running this option called open connection and log debug. Ignore this comment. That's just me testing. But I'm only running these two lines. So let's first, this log debug. I like this one because I have a function. The last one down here is called log debug. And then it actually says if debug is true, then print debug message. So any message, you can see it's coming into the function. It's coming right there. Is being printed if we're debugging. Meaning this message will always be sent to the debugging printer, but it won't always show unless this debug is true. It is true when I click this check mark. So you will see this in many places of my code. I also do this in the Arduino code. I have a boolean called debug, and it's usually false. If it's true, it's going to print out serial debugging messages. So that's what this line does. The open connection, that's the important one. Let's check that out first. So let's close start, open connection, and you can see it's a bit longer. It's maybe 20 lines. If my data, that's our serial connection up here, is different from null, that's anything at all. If it's anything, then we're going to check, is it open? Is open is another way of asking the computer, is this connection active or not? Do we have a connection? If it is, then we're going to send write line 01 as the first thing. And 01, if you remember from the last video, that is the command to switch the LED off. And then we're going to close the connection, and then we're going to log debug already open closing. Meaning if for some reason there was a connection or error connection, or you have been messing around with your USB ports and who knows what has happened. It's just going to close the connection if there's a problem. If it's not open, that's what we usually want. That's the default option. Then open the connection, start the connection with the Arduino. Set a timeout, meaning if there is nothing happening for 10 milliseconds, just close the connection or time out the connection if you want. Move on. That's very important because when we're sending messages back and forth, if nothing were coming back, the computer would just stop or the program would freeze and nothing else would happen. It actually still does, but it's only for 10 milliseconds. Now, if you remember from the last video, we also had a 10 millisecond delay on our buttons. So now we need to add those up. That actually means we are, in worst case scenario, having a 20 milliseconds delay on in total from when the user clicks a button to it's being done in the code, and maybe even another 10 from happening in the code for the computer to process the information to put it on the screen. So that's 30 milliseconds. Something to consider and something to keep in mind if you're working on something that requires reaction. And then, of course, again, we're going to write a message, connection open. And here we go. Start coroutine handshake 2. I'll get into that in a minute, but first let us just finish our open connection function. But this one, let's do this so we don't forget it, because we need to talk about that. If the connection is null or nothing, or the connection, is open, it's going to test, is the connection open? Then it's just going to write, is it open? Else it's going to say, setup is null, check your settings, something is wrong. I don't know what, but something is wrong. It's not able to connect. That's it. Let's go back to this one. Start coroutine handshake. Start coroutine. That's a message for Unity to start. Well, imagine you're driving down this road, and then there's a car in front of you. That car is trying to give a message to you, but you can't see it, so you are slowing down and waiting. Oh, I can't see the message. What coroutine actually is, we're going to add another lane to this highway. So now we have 2 lanes. We have this lane that's free, and we're just driving down. Then we see there's a car over in the other lane, and he has a message we want. So then I'm going to drop off another car that's driving next to me, and he's just following me up to that connection, and he's going to get the message from me while I drive on. And eventually, if he gets a message, he's going to catch up to me and say, hey, the message was this. And if he doesn't catch up, well, that's just too bad. The package is lost and I don't care about it. I'm just going to look for a new message along the way. But the point is, I'm not stopped at all. I'm able to continue. And this is what we're doing here. This has to do with our timeout as well, because if we're not starting coroutines, we're actually just blocking the entire process of the game, and it's not able to run until we're getting feedback from something. By doing this, we're able to start a separate function, or a separate, let's call it something else than a function. Let's call it a separate lane, and it's going to run on its own and then later catch up to us. But we're going to call this function handshake. So we're taking our handshake and putting it somewhere else and waiting for it to come back, or maybe not. Let's look at our handshake. You can see it takes the input number 2 as well. Let's close this bad boy up. Handshake. Oh, there we go. That's a enumerator. That means we're working with time. Yield, return new, wait for seconds, wait time. That means we asked it to wait 2 seconds. And then it's going to write 01. So what we are in effect doing right here is, where is our connection? When we open our data, we set a timeout line, we say connection is open, then we actually just say to the computer, go down here with the number 2 and wait 2 seconds, then you write 01 to the Arduino, meaning after we start the game or make a connection, wait 2 seconds, then switch this light to green, meaning you allow the connection to actually happen, you allow things to work. If we don't have this short wait time, you can maybe set it to half a second. I just have it to 2 because maybe that button was easy to press when I was writing the code. You need a delay. If I didn't have this delay and I was writing this line instantly after the connection was made, even though it's 4 lines down or 3 lines down from the connection, that is still instantly. Nothing will happen. It would not be able to register the command. It would be too fast for the Arduino. So we ask it to wait. Please wait. And when you have waited 2 seconds, continue and turn on the LED so the player can see the game is on. And that's our start coroutine. So next thing we have this one called update. In Unity, just like in the Arduino, update is run regularly. In our case, the Arduino reads every hertz. On the PC, we are reading every frame per second. Or this update function is run once per frame per second. Meaning if we were to add a delay, we could add a lot of lag if we wanted to. But all I'm doing in this one is calling the function read input, and there is nothing else in here. Okay, read input. Well, again, we're using a function that allows us to continue our work, just like I spoke about with the coroutine. This try function does something very similar, because if I just did this one right here, read line, I tell Unity, read this sign, but imagine the sign has no letters on it. Well, then you would stop and wait for the letters to appear, or at least a computer would, because they're dumb. So while waiting for the letters to appear, you can't do anything else. You're just standing there waiting for the letters. Nothing will happen until your timeout, which is preset to 10 seconds or 10 milliseconds, and then you will move on. If we do this instead, we would say, try to read the sign. Oh no, there's nothing, and we'll just move on anyway. But if I, for example, has this input, my data read line, if you remember the Arduino, whenever I pressed a button, it would write a line called 1, 2, 3, or 4. So if I pressed button 2, this would be able to read line 2. Oh, he's pressing 2. And then I can print it to my text if I wanted to. But the point is, I just have this input, and I store the user's input as input. That's it. We have a timeout. That's just in case the computer might think, hey, let's stop up and wait for an input. No, let's not. That's basically it. That's all this script does. Well, it has a few other things. You can see I have this one. On application quit, that means if the player quits for some reason, rage quits or whatever, I make sure my connections are closed. So the first thing I write is 01, send to the Arduino, so it turns the LED to red, and then it's going to close the connection after that, and then write in the console connection closed. Then it can end the game or program if that's what the player is wanting to do. So this was all about handling the connections to the Arduino and getting the input into Unity. Only other thing we have now is our game controller. A game controller, I'm not going to run over the entire script. I'm just going to run over the parts where we are getting this input, which is stated right here. You can see it's a public string input, and putting it into the game. So I would consider this system controller, as I called it right here, a driver. That is my driver for my Arduino, because it's handling the connection and forwarding the input from the Arduino into the game. The game controller, well, that's just the game itself, but let's take a look. Yeah, I don't know why you have to zoom like this in the new UI. It's quite silly. Anyway, game controller, it's right here. And I have this script called game A. And you can see there's a lot of values that are empty, and there's nothing here except I have these items, which is sounds and my text boxes. But let's hit play. Now you can see I have a input, get input from system controller. So it's actually able to find the system controller, and it's going to read the input. If I press something on my controller now, you should be able to see it right there. And you can see I press 2. And yeah, it's actually updating correctly. And here you can also see the number generated. You can see counting if we're adding score, or you can see the high score. We can change that if we wanted to. All sorts of fun things. The only really interesting thing are this one called get input and this one player input, because these are the two things that are from outside input. Those are our hardware inputs. Let's check out the script. Here we go. Already pre-zoomed in. Let's minimize these a bit. There we go. So here we have the script, and I have my initial setups, as you can see. Those are these things over here, and they are right here. Public game object get input, public string player input. Those are the two things we need to worry about. Everything else is just game related. So when the game starts, first thing it's going to do is get input equals the game object find system controller. And system controller is this one, and we're just using this name right here. As you can see, it's not even tagged or anything. With this name, we're just going to store it as get input. And then we're going to start the game. The first round is not going to be timed, so we're just resetting the game, generating a number, and setting the score to 0, getting the high score from saves, and setting it to the screen, playing a sound, meaning we are ready to play. That's it. Only one thing we got here with which were really important. That's this part right here. Nothing really to explain about that. Oh yeah, there's one thing to explain about that. The reason we are getting this is because in our system controller, this input, that's actually this one we are trying to read, or going to read in a bit, is a public, and you can see it's public right here, public string input. So this script is attached to game controller, a system controller, and we are then finding it with anything else. Let's hide the starts. And then we have a lot of different things. They are mostly related to the game, but down here we have this one, update. We have another start coroutine update input. And the reason for this coroutine is because, again, we don't want the computer to freeze, or sorry, just Unity to freeze while we're waiting for the player to put some input in. We just want to read the input. If there's no input, we just want to continue. Otherwise, it would be a pretty silly game. Again, enumerator, we're working with time here. Yield, return new, wait for end of frame. Instead of last time where we were using wait for seconds, this time we're just checking once per frame if there is an input, not each second or millisecond. And the way we read it from the other script is actually we take the player input, which is equal to get input, and up here in the start, get input was this game object. So we could type this entire thing, so copy. We could do something like this, where we do, I'm just going to type a random thing now, string test. So I could do test equal this part, get component com dot input. There we go. These are the same things, except I'm just using a reference. This part is the same as this part. Just to be clear, and the reason you're using this as a reference is because you might be using it multiple times throughout your code. Anyway, our player input equals the game object, and we're going to get the component attached to the game object called COM. And remember, that is this script, it's called COM. And we're going to get the public string called input. That's it. Now we have our player input in this script, and we can run a test, and you can see check test. That's our next one. If player input equals to the number generated, the random number generated, then player win and do winning stuff. Add a number to the score, reset the game, start a new game, etc. That's basically it. Really simple, but it just takes a lot of work to get working, and there's a lot behind the scene actually going on. So I really hope you got something out of this. I'll post all the code for this Unity session again on my forums in a separate post related to this video. If you have any comments, suggestions, please write them below in the description box below. Sorry, comment box. And subscribe. I'll see you next time. Thanks for watching.